Alright, so today we're looking at AP Stats 2019, question number 4. Tumbleweed, commonly found in the western United States, is the dry structure of certain plants that are blown by the wind. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that Kochia plants are becoming resistant to most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly sampled Kochia plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected Kochia plants were resistant to glyphosate. Do the data provide convincing statistical evidence at the level of alpha equals 0.05 that there has been an increase in the proportion of all Kochia plants that are resistant to glyphosate? Okay, so the trick here is that it's saying, do the data provide convincing statistical evidence, blah blah blah. So you need to know you have to do an inference test. So now specifically, it's saying if there's been an increase in proportion. So we're doing a difference in proportions test. So we're just gonna call them P1 and P2. That's the easiest way. So our null hypothesis is P1 minus P2 is equal to 0, meaning that there has been no change, or that there has not been an increase, because if, and we'll define P1 and P2 in a sec, and H alt, or just HA is better, I don't know why I did that, H alt, if there's been an increase in the number of, and if P1 is 2014 and P2 is 2017, then P1 minus P2 would be negative or less than 0. So now we can say, now we have to actually define each thing. So we're going to say P1, the true proportion of all Kochia plants. And again, I'm just taking this straight from the text. True proportion of all Kochia plants that were resistant to glyphosate in 2014, and P2 is essentially the same. It's the true proportion of all Kochia plants that were resistant to glyphosate, not glyphosate in 2017. Now, what you can even just do P 2014 minus P 2000. Like for example, you can just do this: H not as P 2014 minus P 2017, and alternate. Oh, sorry, equal to 0. And P 2014 minus P 2017 less than 0. You can always do that, but I don't know if this counts as enough context, so I think you should always just do that. The last thing we have to do is state our alpha level, which is equal to 0.05, right? Now, we're doing a 2-sample z-test for P1 minus P2. This is a z-test, so meaning we're going to have to actually pull the proportions. But that comes later. So let's label this as, in our 4-step process, this is state, right? Now we're going to head to the plan. And in plan, we check conditions. And first we name the test, and we check conditions. So like I just said, this is a 2-sample z-test for difference in proportions slash P1 minus P2. You might as well just say both, because you never know if they count one piece of context over the other, so it's just safer to use both. P1 minus P2. Good. Our first condition is random. Remember, this is basically ren. So random. Let's see. I'm going to use the highlighter here. 61 randomly selected Kochia plants, and then 52 randomly selected Kochia plants. So now we can say, so now here's the thing, right? Because they occurred in 2 different years, the one sample did not affect the other sample. So they are independent, but we'll come to that in a sec. So we're going to say random, just quoted exactly from there. 61 randomly selected blah blah blah. So 61 61 randomly selected Kochia plants, and then the other one, I believe 52 randomly selected Kochia plants. Okay, good. That's random. Now we're going to check independent. This is basically not large count, sorry. This is our 10%. That N is 1/10 of the population. So we can say that there were at least 610 Kochia plants 2014, and there were at least 520 Kochia plants in 2017. So we can say there were at least 610 Kochia plants in 2014. Sorry, that's the incorrect use of a semicolon. And there were at least 520 Kochia plants in 2017. This is our large count, not large counts, this is our 10% condition, that little n is at least 1/10 of big N. That our sample is at least 1/10 of the population. Sample size, 1/10 population. Okay, now normal. And in normal, this is large counts. We're basically checking N1, P1, N1, 1 minus P1, N2, P2, and N2, 1 minus P2 are all greater than or equal to 10. So for N1, P1, that is literally just going to be, let's see, 19.7. Hold on one sec. Right. This is why, what I said earlier. This is a 2-sample z-test, so we have to pool the proportions. So I'm gonna state this. Star, this is a 2-sample z-test. Therefore, we need to pool our proportions, okay? So this is pretty simple. All you have to do is this. x1 plus x2 over n1 plus n2 is going to equal your p c hat. Okay. So let me grab a calculator. You're gonna do, it's the proportion, or it's the percentage that were resistant to glyphosate times its total divided by the total. So let me explain it with more detail. So in 2014 we have 0.197 times 61 and that's 12.017. And then, hold on, let me just confirm this before I go on. Let's see, 0.385 times 52. That. So this plus this, 61 plus 52. And our pool proportion is, okay, so this is what you have to do. It's basically, so x1 is going to be 61 times 0.197. x2 is going to be 52 times 0.385, because these percentages are the percent of those plants in the sample of 52 or 61 that were resistant, and divided by the 61 plus 52. PC hat is going to equal 0.284. Okay, so now what we have to do, now we take this pool proportion and we put it in here, in here, in here, and in here. And for the first one, we're going to do 61 times 0.284. You get approximately 17. The next one, 61 times 1 minus 0.284. You get approximately 44. Then 52 times 0.284 is approximately 15. And 52 times 1 minus 0.284 is approximately 37. Therefore, all conditions are satisfied. Okay, let's just check. We named our test. We did random good, independent good, normal good. We showed the pool proportion calculation. Okay, now we can go ahead and actually calculate our z value. So now state plan. Now it's time to do. Time to do. Do. So z is equal to, it's going to be your P1 minus P2 minus basically 0. It's this is your null. This is your alternate, this is your null, and then this is all over the square root of PC hat times 1 minus PC hat over N1 plus the same thing, PC hat 1 minus PC hat over N2. Remember, you should always give this general formula. So now when you go ahead and plug in, equal, it's going to be 0.197. Yep, 19.7. Times, or not times, minus, I believe, 0.385. Yep. Minus 0.385 minus 0 over, and this is going to take a while. You know what? I'm not even going to, you know what? I'll just write it. Over 0.284. 1 minus 0.284 over, and then we defined P1 to be, make sure you're consistent, so P1 is 2014, so N1 will have to be 61 plus the same thing, 0.284, 1 minus 0.284 all over, I believe this is 52. So now we're going to do, go to your calculator, alpha y equals 1. That makes a fraction for you, so type in 0.197 minus 0.385, close parentheses, minus 0. And then second square root, again, alpha y equals 1. 0.284 times 1 minus 0.284 divided by 61 plus 0.284, 1 minus 0.284 all over 52. And then you're going to get a z of negative 2.21. Negative 2.21. Okay. So now you can do is this. You go ahead and second vars, normal CDF. Your lower value is going to be negative 999999999999999. Your upper value is going to be negative 2.21. Mu for a z-curve is always 0. Standard deviation for a z-curve is always 1. Go ahead and paste. And you get a p-value of 0.0136. So now to show your work on how you got that p-value, you just do this. So draw your curve, and then you can always get that p-value from the back of the reference sheet. Okay, so here's your mu, which is equal to 0. Standard deviation is equal to 1, because this is a z-curve. Negative 2.21. You basically want everything that's below. Everything that's below. So what you do normal CDF, lower, negative 9999999, upper, upper is going to be negative 2.21, mu is going to be 0, standard deviation is going to be 1. This gives you a p-value. It's going to equal 0.0136. Also go ahead here and state negative 2.21, and then your p-value on the inside. It's just the standard notation. Okay. So this is your plan. You got your p-value. You got your test statistic. So now we can go ahead and conclude, but also make sure you box this, and then also label. So here's your test stat. This is your p-value. Okay, good. Now we can go ahead and conclude. So we stated, we planned, we did, and now we're going to conclude. Conclude. Okay. So now remember our alpha value was 0.05, right? So because our p-value 0.0136 is, one sec. Because our p-value 0.0136 is less than our alpha value of 0.05, we will reject the null hypothesis. Okay, so this is the first part of the statement. You gave your context. You said because our p-value blank is less than, greater than, or equal to our alpha value of blank, and then your decision. So now you scroll back up. You go back to the original question. Due to the data provide convincing statistical evidence that there has been an increase in the proportion of all cochlear plants that are resistant to glyphosate. Glyphosate, right? So, because you reject your null, you do have convincing statistical evidence. So we can say, now, so again, because we rejected our null, we have convincing statistical evidence. Therefore, we do have, and again, I'm just copying straight from here. We do have convincing statistical evidence. Convincing statistical evidence that there has been an increase. Evidence that there has been an increase in the proportion, I believe, in the proportion of all cochlear plants and the proportion of all cochlear plants and all the cochlear plants that are resistant to glyphosate that are resistant to glyphosate. And you're done. So now let's just make sure that we did everything, because these confidence levels, you can mess something up. Okay, so the first part we stated, gave our null, gave the alternate, we gave context for both, stated your alpha, plan, you named the test, you checked your conditions, you did your pool, because this is a two-sample z-test. In your did, you show your general formula, you calculated your z-value, then you showed how you found your p-value, you used normal CDF, and you stated all this, and you concluded an accurate conclusion. Now let's just make sure that we've answered everything from the question. All it asks, I believe all it asked us to do was this is two-sample z-test. Because all it asked for was, do the data provide convincing statistical evidence? Those are your keywords to perform a test. Thank you.